How and why we tested the Norcold high temperature monitor or recall. In the year of 2014, we attended a seminar presented by the Northwest Technical Representative for Norcold. During the seminar, the Norcold rep stated that there was no difference between their high temperature control and the ARP, which has been rebranded as the Fridge Defend control. In the 6 years that have passed, we get frequent reports that Norcold is continuing to make this claim, in spite of our posting a letter from Norcold that states the contrary. That is, the Norcold high temperature control does not protect the cooling unit like the Fridge Defend does. It allows leaks. We had a predicament because the Norcold letter went on to state that the temperature that the Norcold control turned off the heat was 800 degrees Fahrenheit. Thus, we needed to do some engineering calculations to see if it was safe to test this control on a functioning refrigerator. We ran some initial calculations which confirmed that it was not safe to test the Norcold control on a cooling unit. A failure of the cooling unit while in close proximity performing a test could cause harm to us. Next, we turn to Norcold's purpose statement found in the kit installation documentation. The kit is to detect improper operation of the cooling unit by monitoring the surface temperature of the boiler. As a result, we used a pipe to simulate the boiler. This keeps us safe from high-pressure explosions and resulting fire by using a real cooling unit for the test. After all, Norcold stated that it is surface temperature we care about. Thus, we placed the Norcold sensor on a pipe and put a temperature sensor between the Norcold sensor and the pipe to measure and record the actual surface temperature of the pipe. Our selection for the surface temperature sensor was a precision, calibrated, and fast response time sensor that can measure temperatures up to 871 degrees Celsius or 1600 degrees Fahrenheit. The next step was to determine the Norcold safety kit circuit method of operation. In short, the Norcold control takes a signal from the sensor, measured at node 4 in the diagram, and amplifies the signal. We measure this amplified signal at node 1. Data logging the two signals on the Norcold circuit, where the x-axis on the plot is the Norcold sensor input signal, node 4 in the circuit, and the left y-axis is the circuit amplifier output, node 1 in the circuit. The result is the blue curve. Purple dots compare the y-axis Norcold sensor to the temperature sensor that is between the Norcold sensor and the pipe. These values can be read on the right y-axis. In conclusion, we show you one of our early tests where we insulated the pipe the same as the boiler insulation found on the refrigerator cooling unit. We came to find that if the pipe was insulated, the results were not too much different than without the insulation. The largest factor affecting the temperature at which the Norcold recall would trip was the ambient temperature. This is because Norcold designed their high temperature device without any temperature compensation, which is needed for a precise control system. In order to meet the rigorous standards set by the scientific method requirements, the test must be repeatable. We tested 5 of the Norcold high temperature controls, including Revision B, Revision D, and Revision E. All of the Norcold recalls performed with similar results in the same test conditions. To confirm repeatable circuit results, we used TINA TI for a computer simulation of the amplifier circuit. Our measurements on the circuit are confirmed by the computer model. Please see the companion videos to this series, which include the actual test of the Norcold high temperature control and calibration of the temperature measurement.